Hi, I'm Jack Erickson from MathWorks, and I'm here to talk about deploying deep learning applications on FPGAs from MATLAB. So FPGAs have become popular for deep learning inferencing in embedded devices because you can custom program them to deliver low latency with an efficient form factor and power envelope. However, when you're designing deep learning networks for edge devices, you really need to keep the system requirements in mind. So if you take an example here, like this industrial inspection application that we'll be using later in the demo, it probably has requirements for a high camera frame rate feeding it in and some pretty high accuracy to inspect defects. And those might be handed off to the person designing the deep learning network. And they design a network and hand it off to the hardware team, who has to try to meet that high frame rate requirement by delivering low latency with efficient resource usage and power consumption. So with the heavy computational requirements of deep learning, that can be very challenging when it gets to hardware to trade off those factors against the network's requirements. And to visualize what that looks like, if we take a simple deep learning network like AlexNet and just look at the first convolutional layer, when that image frame comes in, you slide these filters across. So it's 96 filters, and for RGB, it's 3 deep, and they're 11 by 11. And single precision floating point is 32 bits. So that's 140K bytes, which is not too bad. And then striding it across, each stride itself is an 11 by 11 by 3 matrix multiply accumulate, which generates 96 by 55 by 55 results. So those are the activations that get passed to the next layer. And what that is really, it comes down to 105 million floating point multiply operations.